Hi, my name is Joe and I'm a solutions engineer at NextMove. In this video, I'm going to walk through how to implement a custom value function to solve a routing problem when cost varies based on different types of drivers. In this example, tasks can be assigned either to employees who are paid by the hour or gig workers who are paid by the stop or by the task. The goal of our optimization is to minimize the total cost we have to pay to assign all of the stops or tasks, while also conforming to all of the constraints that we have. The starting point is the NextMove routing template. This template is available directly through our command line interface, or CLI. If you do not have our CLI yet, you can install it by going to cloud.nextmove.io/signup, sign up for a free account, and follow the instructions to install our CLI and SDK. From there, you can initialize the routing template from which we are about to start. Since we're starting from a template rather than from scratch, I'm going to show both the template on the left to show you what you'll be starting with, and on the right, I'm going to show you the new code that we have with a few additions. So, for every optimization model in NextMove, we have to define the structure of our input data. Our template includes quite a few fields here that map to various options in our routing solver for various constraints. In our case, we need to add three new fields to our input. The first is vehicle types to indicate which vehicle is of which type, and we'll indicate those with integer values to be simple. We also need an hourly pay rate, which is how much we're going to pay our employees per hour, and a task pay rate to represent how much we're going to pay our gig workers per task. I will quickly look at our input JSON here. On the left is the input JSON that comes prepackaged with the template. And on the right, you'll see I've added those three fields here. We have vehicle types of 0 and 1. We have hourly pay of 25, so you can think of that as $25 an hour. And we have task pay of $10, so think of $10 per task. So that's all we need in terms of input data in order to change the value function to account for these costs based on these driver types. So in our router, the template already comes with a range of options which map to various constraints, as we've discussed before. We're going to add the update option into our solver here, or into our new router. The update sets the collection of functions that are called when transitioning from one store or state to another in the router's decision diagram. Search for the best solution in the time allotted. And you'll see here that updating information is useful for two purposes, one of which is setting a custom value function, which we're doing right now. This option takes the following arguments: the vehicle updater and the plan updater. The plan updater replaces the value function of the full plan. Since we're solving for a multi-vehicle scenario to allocate costs between vehicles, this is the one we're going to be most interested in, and the vehicle updater we will basically leave the same. But we need to have both a vehicle and a plan updater involved here. So, most of what we're adding is outside of our solver function. We have to implement the plan updater interface, and in order to do so, we create a new type of plan data, and then that plan data will accept the input data that we need here, including the vehicle types, the hourly pay rate, the task pay rate, and also some penalties to ensure that we don't leave any stops unassigned. So, to create a value function, we use the update here, which takes the implement the plan updater interface. Plan updater interface takes a route.partialPlan and a slice of partial vehicles, and it will return a plan updater interface with an integer value, for the plan value, along with a Boolean value of whether it's been updated or not. So, each time the solver finds a valid routing solution based on all the constraints, we're going to evaluate the value of that solution based on this function here. So, to start with, we need to set the value at 0 so that we reset it each time. Then, we're going to range through the list of vehicles and determine the cost based on vehicle types. So for each vehicle, we're going to start with a value of 0. If the vehicle type is 0, it's an employee. So the cost is going to be based on the total time of their route. So we see here, we're going to get our route ETAs and estimated times of arrival and departure. And we're going to set a route value. The route value is equal to the time length of the route from the end of the route to the beginning of the route. So the total time duration of the route in seconds, divided by 3,600 seconds in an hour, multiplied by the hourly pay rate. And that's going to be the value of each vehicle for which is operated by an employee, is the cost per hour times the number of hours they're working. Vehicles of type 1 are gig workers, and they're paid by the task, so their cost is a little simpler, and it's fixed based on the number of tasks. To find their cost, we multiply the length of their route minus 2, because every route has a start and an end location, which are not assigned tasks. So we need to remove those from our count to count only the number of actual tasks or stops that they're being assigned. Then we multiply those by the task pay rate to get the value of the route if it's a gig worker. And then we're going to add that route value to this new value for each and every vehicle as we loop through. Once we've looked through all the vehicles, we also want to make sure that there aren't any unassigned stops. And for that, we will use this here to add a penalty for those unassigned stops according to the unassigned penalty values from our input. We didn't look at those because those are standard options, but since we're customizing the value function, we need to account for those here as well. And then, once we've calculated this new value, this function returns the plan updater, the value, and true to say that it's been updated. And that's it. That's essentially it. With this approximately 15 functional lines of code, we have completely changed how we optimize our routes to be based not on our default value of total duration, but instead to be based on the total cost, based on how we've defined our costs here. As we discussed earlier, there is a vehicle updater interface. However, since we aren't really concerned with optimizing costs for a single vehicle, we always basically return false and the value here of the partial vehicle, which is just the length of the route. But again, this only applies when there's a single vehicle. So in order to pass these two arguments, the vehicle updater and the plan updater, we need to define them here along with our input. So P is plan data, and that plan data consists of, from our input, vehicle types, the hourly pay rate, the task pay rate, and the penalties, which we've looked at, which all map to the types in the plan data. And that's it. That's all it takes to implement a custom value function. So let's go ahead and run this and see the output. You run this with the same command that runs the base routing template file, which is in the README that's included with the template. So we've run our template, we've gotten a solution. So let's go ahead and look at that solution. So here we have our route output. We have vehicle 1, which has a start and a list of stops and an end. And then we have vehicle 2, which has a start and a list of stops and an end. So because of the constraints that were applied in our template, there was only one feasible solution, since some of our constraints included a backlog that requires certain stops to be assigned to certain vehicles. Obviously, your data set will be somewhat different, and you'll likely find many solutions here. But that's why that's the case here. And that the value of this solution is 75. So let's look at the routes and assess what that value is. The first vehicle was an employee. So the employee had a route duration of 3618, or just barely over an hour. So since our hourly rate was $25, we've added $25 for 1 hour of work for this one vehicle. The second vehicle was a gig worker. This gig worker was assigned 1, 2, 3, 4, 5 tasks. At a cost of $10 per task, it costs $50 to assign this gig worker these 5 tasks. 50 plus 25 gets us to our value for this solution of 75. That's how simple it is. And then from here, you can begin to update your function to take into account other constraints or factors, adjust your costs to make different decisions, and maybe consider different constraints that may help to change that cost, either higher or lower potentially, depending on what you choose to include.